Bismillah ar-Rahman ar-Rahim. This is for topic 9. What is the main conclusion of the photoelectric effect experiment? Actually, we said it depends on the light has particle nature. Light is basically photons. So this is the conclusion of the photoelectric effect experiment. Which of the following, best defines threshold frequency? What is the threshold frequency and threshold wavelength? It's the smallest frequency and the largest wavelength that can cause electrons to release from the material. We know that energy equal to H times F. Also, we know that energy equal to H times C over lambda. For the work function, which is the minimum energy, so it's H times F0, or we can say it's H times C over lambda 0. Those are threshold frequency and threshold wavelength. Now, if we increase the frequency, we increase the energy. So the lowest frequency is the threshold frequency. If we decrease the wavelength, we increase the energy. So this wavelength, our threshold wavelength, is the largest wavelength that can cause electrons to be released from the material. Next. Now, if the intensity increase, what will happen? We said intensity increase means more photons are hitting the surface of the metal at the same time, while the energy of each photon is the same. The energy of the photon equal to HF. So frequency is not changed. So the energy of each photon is the same. The only difference, we will increase the intensity, that more photons now hitting the surface of the metal means more electrons will be affected. So the number of the photoelectrons will be more. So we are now talking about A or B. Those are cancelled. Now, what about the kinetic energy? Kinetic energy depends on the energy of the photon, because the kinetic energy equal to the energy of the photon minus the work function. But the energy of the photon is not changed because the frequency is not changed. That means the maximum kinetic energy will stay the same. Okay? Now, next question. Question number 40. The maximum kinetic energy depends on the frequency or wavelength, right? Because the intensity, as we said, the intensity will not change the kinetic energy, because it will not change the energy of each photon. Okay. Next. For this graph, which is kinetic energy and frequency, the threshold frequency is this one. When the electrons start to be ejected, it will start to have kinetic energy. Before this frequency, there is no ejection of the electron, so there is no before this frequency there is no ejection. So this frequency, when the ejection starts, this is the threshold frequency. So it is 2 times 10 power 15 hertz. Here I want to highlight something. Always look at the axis of the graph. It will give you the unit. Of course, it will identify what is this axis represent. but also it will give you the unit of the value here. Also, sometimes like this situation, it includes some multiplications. يعني هون in this case the frequency is multiplied by 10 power 15. The kinetic energy is multiplied by 10 power negative 19 joules. So it is very important to realize this. Now, use the data from the graph to calculate Planck's constant. From this graph, h equals the slope. And that's equal. Choose any 2 points. There's already 2 points here, 2 clear points. So 24 minus 12 over 6 minus 2, and again don't forget to use the multiplications we have for the sorry, not minus 2, minus 4 I mean. Okay, so here it's multiplied by 10 power negative 19, and the frequency is multiplied by 10 power 15. H equal, it's okay, 12 to 6. 6 times 10 power negative 34. طبعا the unit of Planck's constant is joules times seconds. You can use any 2 points, no worries. Any 2 points, but don't forget to use the multiplications. Multiply by 10 power negative 19, multiply by 10 power 15, etc. Okay? And be careful. Here there is common mistake. Some students use 0, 0. This is not right. This is not point of the graph. Clear? Don't use 0, 0 because it's not point from this line. Be careful. Okay. Now for this question, metal with the highest threshold wavelength. Highest wavelength means lowest frequency. Which one has lowest frequency? The potassium has lowest threshold frequency. So potassium. Okay. The stopping potential for potassium. Okay. I believe this is a typo mistake. It should be not potassium. It should be platinum. And now I tell you why. Now, when the frequency is 2 point, okay, also it's another typo mistake. It's not 2.25, it's 2.25 times 10 power 15 hertz. So we are talking about this frequency. Now, we need to find the stopping potential. Now, this is the frequency. Okay. For the platinum, the maximum kinetic energy is 2. So the answer is 2 volts. Why? Actually, kinetic energy or maximum kinetic energy equal E times V, the stopping potential. Now, stopping potential equal kinetic energy over E. And be careful when we use this formula, kinetic energy should be in joules, and this one in volts, and the charge is 1.6 times 10 power negative 19 coulomb. Now, when we divide joules by E, energy in joules by E, we have converted now the energy into electron volts, right? To convert from joules to electron volts, let's write it in this way. To convert from joules to electron volt, we divide by E. So, if the energy given is in electron volt, the stopping potential will have the same number as the energy in electron volt. Clear? So since here the energy is given in electron volt, we can use the same number, but also don't forget to use the unit for the stopping potential, volt. Okay? Now, metal with threshold frequency of approximately 1.1 times 10 power 15 hertz. 1.1, it's the zinc. From the graph clearly, it's the zinc. Find the Planck's constant from the graph. You can use any line and any 2 points, but if you use, for example, the zinc, you need to choose 2 points from the zinc. If you use the line of the platinum, you need to choose 2 points from the platinum. Don't choose 1 point from platinum and one from sodium, for example. It's not right. If you want to find Planck's constant, means you need to find the slope. Be careful to use the any 2 points from the same line. And also, don't forget to convert the energy into joules. Also, don't forget to use this multiplication. طيب. So, H, Planck's constant, equal to the slope, and that's equal to, again, you can choose any 2 points. If you subtract any 2 points, you will find that the difference is 3. Not any 2 points, but the ratio will be the same. 3, let's say 3 electron volt. But to convert this 3 to joules, you need to multiply it by 1.6 times 10 power negative 19 over 0.75, multiply by 10 power 15. Now, I use those numbers because those are the numbers in the answer key, but you can use any 2 points from any graph, any line of those lines. So the answer will be 6.4 times 10 power negative 34 joules times seconds. Okay? Now, for subtopic 9.2, Compton's effect, please read it. Now, the shift in the wavelength, delta lambda, equal to h over mass of the electron times c, the speed of light, multiplied by 1 minus cosine theta. So everything is given here. We have constants and given angle. So the constants are 6.63 times 10 power negative 34. This is Planck's constant over mass of the electron, which is 9.11 times 10 power negative 31 multiplied by speed of light, which is 3 times 10 power 8 times 1 minus cosine 45 degrees. Those are the angles, the given, sorry. Delta lambda equal 7.11 times 10 power negative 13 meter. For next subtopic, the Broglie's wavelength. I'm not sure if I'm pronouncing the name right, but anyway, lambda, the wavelength, equal to h over mass times velocity. Lambda equal to h is 6.63 times 10 power negative 34. طبعا should we use 6.63 or 6.6 for the Planck's constant? Should we actually look at the formula sheet? At the top of the formula sheet, you will find the constants. Use it as it is. So it depends on the exam. Look at the exam, the exam you have, and look at the constants. Okay? Over the mass, here we have a given mass, which is 6.6 times 10 power negative 27, multiply by the speed, which is 2 times 10 power 6. So now just calculate lambda equal 5 times 10 power negative 14 meters. That's it for topic 9. Next video, inshallah, will be for topic 10.